So before I begin, I'd like you all to take a second. I want you to think about the last time that someone came to you and said, that thing that you built saved me so many hours of work. It has made my life so much easier. You are awesome. Thank you so much. Product thinking is a way to get more of those moments. My name is Jacqueline. I'm a software developer, and I've been working in data at Yelp for the past 4 years. I've been using product thinking ever since 2017, when I was working in applications for a bank. I still use it today, but there's some trade-offs and challenges that come when you're delivering to internal customers that definitely leave me wondering if it's worth it sometimes. These are my talk resources. For the type of person that likes to wait until the end of a talk to download the resources to see if it's interesting enough, don't worry, I have this same slide up at the end. If you'd like to download them now and peruse through what I got to say, it's right here. I do think this talk is really interesting. I've got a lot of good stuff to say. So if you could hold your questions until the end, I promise to try and take time to answer as many of them as I can. Product thinking was originally made for a context where we were delivering to external customers. We needed to know what they wanted and what they needed so we could build something they loved. It is incredibly powerful in that context. But if you take anything that has been built for applications and you just try to port it over into data and platform engineering, it is not going to be straightforward. It can be downright hard and sometimes feel impossible. When I struggle applying product thinking in my data context, I go back to the last place that I saw it work, at the bank. And I remember the core of what actually makes it work. If you imagine a bank, you're probably thinking of somewhere conservative, risk-averse, slow to change. That is where I worked. Nobody took risks, except Alex. Alex was a director at the bank, and she had a reputation for asking uncomfortable questions. One in particular was, why do our products only work for people with money? She was laughed out of more than a few boardrooms for that question. But at the time, in 2017, about 20% of the Canadian population was underbanked or unbanked. That means they didn't have access to things that most of us take for granted, like bank accounts and credit cards. And she wanted to make a bank that would work for them. She persisted and somehow got the CEO to give her 3 months of runway to investigate if this was a viable solution. She came back with the MasterCard debit card. At the time, this was not common in Canada at all. When we built that bank, we were one of the first banks to offer it. This is a card that interfaces with the MasterCard network, so you can use it wherever MasterCard's accepted. But as you spend your money, unlike a conventional credit card, it deducts it directly from your account. So you don't have to worry about remembering monthly bills. It also doesn't require a credit check. So this was the first time that our customers who were underbanked and unbanked, who might have trouble passing that credit check, were able to make purchases online without needing to rely on their friends and family for help. And we made money off of the interchange fees. It's that small percentage that gets charged on top of every transaction on the MasterCard network. This was a viable revenue stream. She didn't just come back with a credit card, though. She'd found things, new technology, new ways of working. And she figured out a way to frame this bank as a win, or frame this project as a win. We were afraid to change, so we were falling behind, technically. She went up to the CEO and she said, let's build a subsidiary. Let's build a bank specifically for people that banks don't build products for. This is where we're going to test out the new technology. This is where we're going to try out those new ways of working. And when we can prove that they're viable and we don't risk our main client base, that's when we bring it back to the main bank. She left that meeting with funding for a year and a mandate to build a bank for people that no one else thought would be profitable. This is one of the core values of product thinking. Find wins for the customer and the business. For data and platform engineers, it can be hard to justify changes or projects that we want to take on. Profit is not always directly obvious from the improvements that we make. And sometimes the impact of what we do can feel invisible. When I hit that wall, I think of Alex and how she reframed the impossible. And I start asking myself, okay, where's the win for the customer? Where's the win for the business? At that point, things can start to move. We had another problem, though, with that bank. We were not our customer. We worked for a bank, and we were building an app for people who were unbanked or underbanked. Their experiences weren't ours. So we needed to get our product out in front of them as quickly as possible before we even hit production. As soon as we had something basic, we could sign up, you could have an account and the credit card maybe, we did user testing and showed it to people that we wanted to actually use it. We knew that we'd probably make a few misses, but what we didn't expect was for our sign-up flow, the steps that you take to get into the app, to be universally hated. This was our sign-up flow. Super basic. It makes sense. You press a button, you enter personal details, you verify yourself, and you open your account. The problem with this was this part. We requested banking information, things like your social insurance number, where you were working. If you are part of a demographic that banks don't find it profitable to serve, thinking about money at all is stressful. And this made us look like every other bank out there. They didn't think we'd be different. They weren't willing to give us a chance. The problem is, you kind of legally need that information to open a bank account in Canada. You can't do it otherwise. We had a lot of really great product owners at that bank. And the one who was responsible for this sign-up flow actually took this problem to his team and collaborated with them on a solution. In that meeting, it was a developer who raised their hand and said, well, what type of account do we have to open? See, it turns out it is totally acceptable to have a bank where you log in, you enter some minimal personal details, and you get a balance of $0. That's a web account. And you only open your bank account once the people have, had a chance to investigate the features, see what's available, see how we're different, and they want to transfer money in. It was because of that technical perspective that we were able to make something that really worked for our customers. I am also not my customer as a data engineer. I am not the primary user of the tables that I'm making. I'm spending my time making them. Love the problem, not your solution, is about accepting that your first solution is likely going to miss the mark. You need to deeply understand your user needs and problems in order to iterate and try to find a better solution that fits their actual problem. Once we fixed that sign-up flow, it was universally loved. Like, people were excited about it. It was amazing. We learned something. We were a new bank on the block. There were a lot of other banks out there that people could choose to store their money in. This sign-up flow would be the first place that people actually got to interact with us, so it needed to be good. We knew that our competitors took 10 minutes to sign up online. And don't ask me how we got these numbers, because I don't know. We also knew that our competitors, the people who started the sign-up flow all the way to ending it, it was only 2.5% of the people who started their sign-up flow were able to finish. So we aimed to get our sign-up flow under 2 minutes. You could create an account in under 2 minutes. And we wanted 15% of the people who started our sign-up flow to finish it. When we launched, we hit that 2-minute target right on the mark. And we did pretty good with that sign-up flow. We had a 6% completion rate. It was double what our competitors had. On paper, it looked like a win. But the actual story didn't match that metric. See, there are 5 million underbanked Canadians, and we'd expected around 10,000 signups in the first month. We had a few hundred. And we could see, actually, it wasn't a marketing problem. There are lots of people getting to the top of that sign-up flow. They just weren't finishing it. So rather than saying our sign-up flow was good enough and relying on that metric because it met and exceeded our competitors' metric, we decided to take a look at it again. And this is where product thinking shows up again. We think in outcomes over outputs. Metrics are signals, but they aren't the goal. The goal is an outcome. Does this actually work for the people that we are trying to help? As a data engineer, I'm often asked to build things like dashboards or tables by a stakeholder who's maybe the manager of the people who are actually going to use it. And it's tempting to just go and build what I'm told to build. But I've learned that if I do that, I risk spending a lot of time and energy building and maintaining something that nobody uses. So now I pause and shift the question. Instead of, can I build this? The first question I ask is, will this actually work for my customers? We had done a ton of user interviews. Customers are really good when you talk to them at telling you what's important to them, why they do that thing. They are terrible at telling you exactly what they're doing in production in the wild. We had user observability, something that would tell us what was going on with the sign-up flow. It was a bit of a mystery, though, because we could see plenty of people were making their way all the way through all of the hardest parts of the flow. And right at the end, when they had to press the button to create the account, is when they dropped off. They put in all of the effort. They'd done all of the hard stuff. And then they were just like, maybe not. So we brought some of them in and said, OK, what's going on with this? And when we could point at the behavior, we actually got answers. When we tested our app, we tested it in our offices. People could see our developers at work. They knew that we were official. We looked real. But in the wild, we're just another app. If we were a real bank, we would match their experience with other banks more. It would be harder to sign up for us. So we introduced friction back into our flow. We added a few steps and took a few tips from our competitors. And our sign-up completion rate went up to 24.5%. Iterating early and often is about de-risking your solution by testing it with real users, real data, real systems in production. No matter how much testing you do in a staging environment, there is no way to predict whether the thing you built actually works in the wild until you can get it out in front of real people. And by doing that, we wound up with a win. Our customers had a good sign-up experience, and we actually had them creating accounts. A few years later, our app went viral. We were getting 3,000 new users per day. The sign-up flow was not the cause of that, but that wouldn't have been possible if our sign-up flow had been painful. And our sign-up flow would have been painful if we decided to consider our experiment a failure at any point in that process. Product thinking is about accepting that you're going to miss the mark. and setting up systems that will let you know early if you start to get off track. And when they alert you early, they're alerting you more often, and that can feel like a whole lot of failure. I found product thinking isn't sustainable unless I take the time to learn from the things that I miss and think in data points and discoveries rather than failures. We were trying out product for the rest of the bank, and these were the core values, principles, and practices that it worked with. It was a really happy, accepting failure environment. I wouldn't want to work there. I was developer number 4 at that bank. We hated it. See, at first, we'd come over from the main bank, so we were stuck in a slow bank-style delivery. It took us 8 weeks to deploy anything. We built something, we'd learn it was wrong, and have to wait another 2 months to try something else. And the focus was so much on building things, getting them out so we could experiment with them and try them out with your users, that there wasn't really priority given to improving our ability to ship things. The tension between business and tech became toxic. The business side of the bank wanted us to ship more, faster, so they could do more experiments, and they couldn't understand why we were slowing them down. But my colleagues who were working on the sign-up flow, I spoke to them, I interviewed them for this, and they literally called it the most over-engineered piece of crap that they have ever built. We kept learning, but we couldn't respond fast enough. We actually had to pause delivering things for 3 months and invest in technical foundations that allowed us to keep up with that pace of delivery and experimentation. And suddenly, then, product thinking worked because iteration became possible. When I looked at definitions of product thinking online for this talk to prepare for it, there were many, and many of them, almost all of them, talked about the customer and the business. None of them talked about the tech. We weren't the first people to miss out on the fact that you need to make your code easy to change in order to enable all of the rest. Those definitions, they're not incorrect, but they also didn't match my experience because it wasn't until we were involved as technical people that things started to work. So I've written a developer-friendly definition of product thinking. Product thinking means understanding the user, the business, and the tech, and writing code that helps you test, learn, and adapt fast so you built the right thing. Feels really good, right? Feels easy. It's a bit more tricky than that. And to illustrate that, let's go and take a look at product thinking in the data space at Yelp. I should clarify here, Yelp is not a bank. It's a completely separate company from the one before. It's a website and app where people can leave and find reviews about great local businesses. I mean, we're not going to look at easy greenfield data code. We're going to give it a real challenge today because we've just seen how it works in greenfield code at the bank. We're going to get people off of a legacy table. Like almost any organization out there, Yelp has what I like to call backbone code that's reliable and working in production forever, so long that people have forgotten it exists. That is our old table, which is responsible for logging user events. 5 years earlier, we'd actually found a better data source, and we built a replacement table, the new table. It was faster, it was more reliable, and it used more modern tooling. We knew people would love it. We launched the new table, we promoted it, and we officially recommended it And then we had to face an uncomfortable truth about migrations. They are so hard to frame as a win. From a user's perspective, we're asking them to take time away from their vital feature work to adopt the cognitive load of understanding how to do this transition. But from our perspective, we can't continue, like, we're investing costs in maintaining this table. Like, in order to help them migrate, we really have to understand all of our customer systems, and there's a lot of them. And in data or platform engineering, if everyone is your customer, that's not really possible. So we held off until we absolutely had to. Yeah?
I have a question. So I thought that Yelp's users are mostly people who go to restaurants and bars and stuff like that, not software users. Like, what users are you talking about right here?
Yeah, that's a really good question. So I'm a data engineer. I make tables, I make dashboards. The people who are using that are my users. They're the people that are using my tables and my dashboards. Yeah, it's an internal system. Thank you for asking that. I can clarify it. But yeah, years later, the library powering the old table was deprecated, and we couldn't continue maintaining it, so we had to move them off. I decided to use product thinking and start by finding wins for the customer and the business. Yeah. This is tricky because when we're delivering internally, our customers are also the business. It's really hard to see where we fit in. Product thinking was originally made for a context where we are delivering to external customers, people outside of our company. And in that context, profitability is important. So very often this principle, when we think about finding wins for the customer in the business, we look at profits. And again, that is hard to demonstrate when you're delivering internally. But this principle was never really about profits. It's about wins. If you're generating a ton of profit for your company, but you can't keep up, that is not a win. So when we look at this principle, think about wins in terms of profitability and sustainability. Can you keep up with it? Can you deliver on what you promised? And for me in particular, on my team, I like to reframe this as find wins for the customer and the team. Because if we are maintaining so many things that we can't keep up with them, our customers are eventually going to just lose our systems, even if they love them, because we won't be able to keep them running and functional. A solution is not a win if it helps out users and burns out the team. Or if it helps out the team, but creates really bad friction for your users. I started by trying to frame this as a win for both of us. To all of our teams, I sent out emails once a week for multiple weeks. And I put a big red banner at the top of our documentation telling people, hey, this one's going away. Please use the new table instead. Waited a little bit. Then I went and I checked our data governance tool to see who was using it. One result. I felt pretty good. They even told me that it was legacy and I didn't need to worry about it. Now it's time to get rid of that old table. But I've been in software long enough that I know nothing ever works the way you expect the first time. So rather than deleting it, I'm actually going to just remove access and see what happens with a rollback plan. Good thing I did. We immediately triggered an outage. We recovered quickly, but this helped us understand something. We thought we knew who was using our tables. We'd contacted people, we'd over-communicated, but we didn't. And this is something, in my experience, we believe that we have solved in data engineering, the ability to answer the question, who's using my tables. I have written a whole talk on how most of the commercial solutions for figuring out who's using your tables don't work. Not really for data engineers. That is not this talk, so I'm sorry to leave you hanging on that, but if you want to ask later, we can talk about it. In order to figure this out, though, I'd need to lean hard into the practice of making my code easy to change. And at this point, you might ask, what does this have to do with detecting users? Because in application engineering, we have beautiful unit tests and amazing refactoring tools. And when we say make your code easy to change, we're usually talking about the code. We're not really focusing on the platforms that we use to make that easy to change. And while that code is important, that's not what this practice is actually about. It's about investing in systems that help you make code changes and know that you're making them safely. Things that are not the thing you're directly delivering, even internally. The emphasis on this practice should actually be on the word make, not code. Because even in application engineering, we build things, we use things like CI/CD pipelines, observability, that aren't our code, but they help us change our systems quickly. If application code is important enough for these systems, then our code, which allows people to make decisions about what they build, deploy those systems, that should be important enough for some of these things too. So I teamed up with another developer at my company, in Maria. She is awesome. And we built a dashboard that reliably used a table in Redshift to tell us who was using our data. When we built this dashboard, we wound up with a bit of surprise. We thought, this had been in production for about 5 years. People should have moved. The new table's obviously better. No, we had 37 teams, over 100 individual users, and thousands of queries running against the old table. Something in the new table was obviously not working for them. We interviewed them. We asked them, hey, what's up with this new table? Why aren't you using it? Got some good information, but also some confusing stuff. Like, I had at least 2 teams tell me they were not using the table at all, and I could see that they were. And I had other teams tell me that they couldn't use the new table because it didn't have a column that they needed. When I looked at their code in GitHub, they didn't use that column at all. This is what happens with backbone code. I have trouble remembering what my code I wrote 6 months ago did without looking at it. If this thing has been in production for a few years, sometimes you lose that knowledge. But I was in my least favorite trade-off here. This is a win-lose or a lose-win. Because we had a deadline coming up. Like, we could not continue maintaining this. It would not become supported. Like, it just wouldn't work. But if we didn't continue maintaining it, important code would break. I don't like being in this trade-off at all. And it can make you feel very, very trapped. I was drowning. There were so many teams, and they couldn't tell me what was actually happening with our data. This started to feel like a failure. This wasn't a failure. This was information. Thinking in data points and discoveries, not failures, is really important for platform and data engineers, because sometimes things that are hard in application engineering feel 10 times harder for us, because the application engineering systems have been built to enable those, and our systems, not always. Accepting that you're learning things as you're building things is part of the process. And the thing that I'd uncovered here is the same uncomfortable truth that we learned at the bank. Users can tell you why something is important. They can tell you what they care about. They are unreliable at telling you what they are actually doing with your code in production. And in order to solve that, we needed user observability data. We needed to see who was running queries against our tables. But that's like got PII in it. And you can't just give data engineers everywhere access to all of the queries running against all of your tables. That's not safe. And this is where I got to do a bit of hand-wavy magic, because I asked for help. And somehow, through a collaboration between our observability platform engineers, our data reliability engineers, and our security engineers, managed to get me that data without violating PII. They did magic. That's what platform engineering feels like to me. It's like magic. I am so grateful to these engineers because I would have been completely stuck otherwise. With that access, everything changed because I could see what queries my users were running against my tables. And when I looked at them, I could see what columns they were interested in. Like this event type column. It exists in both tables. But we'd fixed a bug in the new table where some events that were categorized as timing should have been categorized as quote. Consistency is a feature in data, which is almost as important as correctness. If you run this exact same query against both tables, it gives you different results. And the reason is not obvious. They had tried to migrate their query, run into a wall, and given up. No wonder they didn't trust it. Thinking in outcomes over outputs is about understanding if your solution is actually working for your user, regardless of if it should. If the data is telling you it's not working, it's time to re-examine your solution. My initial solution was to get everybody off the table. But there were a lot of people who were still confused. There were a lot of people who didn't know that their code was running. There were a lot of people that, we just needed to give them a plan to move from the old table to the new one. This was my new target. Let's see if we can get teams to get a plan to move. Creating 37 individual migration plans, not my jam. I'm not going to do that. But in application engineering, we encounter similar problems all of the time. We have thousands, if not hundreds of thousands of external customers, and we can't think about all of them individually. So we use something called user segmentation. We group our users by their needs and their problems. So then we only have to think about 5 or 6 customer profiles rather than hundreds of thousands. We can do the same thing with observability in our data systems. Like, take a look at this query, this Splunk dashboard here. This is not a Tableau dashboard, by the way. This is Splunk. You can do the same thing with Grafana. You can do it with any sort of log aggregator. The cool thing about this dashboard is it takes me about 30 seconds to change it and get myself more useful data. I just have to click on something that is useful, like that query. And I'll see all of the individual queries returned, and I see the query that was used to generate all of those individual queries from my log data. I can then change the base query and aggregate all of them together so I can see everyone who's using who's experiencing the same problem. And then I've got to reach out to them, contact them, and let them know what they need to do to change. After using user aggregation, everything started to fall into place. There's obviously some missing data, which we thought wasn't being used, but it actually was. There were some slow queries, which if you ran a special type of query would be slower. My team took those away to fix them. I was left with one pile of users that had queries that should work, but they weren't migrating. But with those queries, it was about a 5-minute conversation to show them the queries and say, what's going on here? I got answers. Half of them were zombie jobs. This was backbone code, so people weren't using them. The other half, well, they were just confused. But this half, this was 16 teams. We started at 37. Just by segmenting them, we got ourselves down to more than half of what our original number was. Iterating early and often is about testing your code in production systems. And to platform and data engineers, this can sound a bit like a risky pipe dream, because our systems aren't always pooled or built to support that. But the person who brought the term observability into software was a platform engineer who was doing it to make it safer to test her code in production. Charity Majors is the author of Data Reliability Engineering and Observability Engineering. And she gave a talk, which a lot of people thought was crazy at the time, called Yes, I Test in Production, and So Should You. The one place where she cautions about testing in production is data. You can still do it, but if I iterate on my table and my definitions in my table once every 2 weeks or faster, I don't wind up with a whole lot of confused users. So what we do instead is we build 2 parallel tables in production, working off of the same inputs, and we have our users test on both of them to let us know what works. And then when they're ready, we migrate them to the new table. So let's start iterating. We're not building a new table right now. We're moving people off of an old one. So my first hypothesis was, okay, they're confused. Let's give them a migration guide. As soon as I did that, 4 teams migrated right away. Nice. And I thought, well, if information is the problem, let's make that information easier for them to access. I set up Splunk alerts that would trigger whenever anybody ran a query on the old table and would let us politely sort of poke them and say, hey, what's going on? You know, there's documentation. Can you move to the new table? With those Splunk alerts, we got 2 more teams migrated. But we got 2 more teams committed to migrating, but 13 teams. That went up. That's not supposed to go up. So the new table, well, technically cleaner, was a bit harder to use. In the old table, we'd actually broken out a lot of columns from the payload of the event so that it was easier for people to parse. But this wasn't sustainable. Not everybody cared about everything that was in the payload, and it was hard to maintain. So when we built the new table, we just put the payload in the table, and people could extract what they wanted from the JSON. JSON is not strongly typed or consistent, and we had more than one way to specify a business ID. If you didn't know about that, it was easy to make, a query that was wrong, give yourself a bug, and not realize what you're doing. This is where we love our problem, not the solution. My team lead and I met up. We used the observability dashboards to understand who would have to extract what from that JSON column. And we realized there was a core set of a few columns that people would really care about. In that meeting, which was half an hour, the week and more time that I'd spent building and maintaining these dashboards paid for themselves because of the number of engineering hours that we saved. So we updated the new table, broke out a few of those most essential columns. And once we did that, things started moving again. Finally, I brought in a deadline. I'm not a fan of deadlines when they're used as threats. You have to migrate by this date, or too bad, so sad, your system's going to break. No. I am a big fan of deadlines when they're used to force a conversation. And because that deadline forced conversations, we wound up with the rest of the 16 teams having a plan to move. There are still 3 teams that haven't migrated. These are important production systems that we didn't know were running on that old table. Now we do. We know exactly what we need to wait for them to migrate. And we know what's blocking them. And more importantly, they know what's blocking them when they didn't before. So they have a supported migration. And we have a plan for those remaining migrations. We've brought together that customer and team value. We started out, sorry, I'm pressing the wrong button. We started out with 37 teams, more than 1,000 use cases. We're at 3 teams with 3 very well-defined use cases. This is what made that work. It only worked because we chose to invest in tools that made our changes safe. The dashboard didn't just help us once. It saved our butts multiple times. You don't need to adopt all of these principles at once. Like even 1 or 2 might help you out. And I don't know your context. So I can't answer this question of, is it worth it for you? Because the tools that you'll have to build are probably very specific to the type of work that you do. But culture isn't just driven by values, it's shaped by tools. And when we build tools that make the right thing the easiest thing, product thinking doesn't just work for the application engineers that we support. It can work for us too. These are my talk resources. If you'd like to download them, they're there again. I have a thank you slide at the end of every single one of my talks. I'm sorry, I should put the talk resources on the thank you slide too. But these are a mix of Yelpers and non-Yelpers who have helped me with this talk. There are some names in yellow right up there. Those are special names. A lot of times platform engineers don't get noticed until something breaks. These are the people that helped me when things got rough and found me those events and made more sustainable solutions for us to continue to get those events. And one of them is here today. I'm not going to say who she is, but if she wants to wave, she can. Yeah. So yeah, if you could give them a big round of applause, I'd appreciate it.